So really nice to have a quick chat with all of you. One of the things that I find so wonderful about this session is that you're all in different stages of a career, but not too far away from each other. So Ashley, you're still an undergrad. Sam, you just started working not too long ago at Starfish, and you just finished your PhD and work at NASA.
Not
right?
Finished. I'm still working.
Oh, you're still working on your PhD, even closer. When did you all know that you wanted to work in space?
Okay, I can start. Yes. So I've actually been interested in space since the 5th grade. I said this in an interview with theCUBE earlier also, but we did a project around 5th grade, and it was about the solar system. We had to pick a planet, and we had to research about that planet. And little me really didn't know that gas giants existed. So gas giants are very different from terrestrial planets like Earth. So they don't even have a surface. And that just blew my mind, and I've never forgotten it. And then going into middle school, I started becoming really nerdy and watching all of these science videos and space videos. And I watched this documentary by Brian Greene. I'm a huge fan of his. And he really inspired me to be sure that I wanted to go into space. And then I wanted to also do something with engineering, because my dad's an engineer, and a lot of people in my family are engineers, and I think it's so incredible. So that's why I decided to pursue aerospace undergrad at the University of Michigan, and then I did a master's at the University of Michigan, specifically in satellite systems engineering, because I started developing a love for satellites.
I could go next. I would say I didn't know I wanted to do space for a really long time. I know that's a very different answer, except I guess like I always knew I wanted to do something data science-y, something computer science, just because I found it really fun in high school. Except when I got to Stanford, there was this club that was very obnoxious about saying you can put things in space, you can make rockets, and I was like, well, gosh, let me just show up. And I went to one of the first meetings, and I decided, hey, let's just try and show up to the satellites team. And they're like, yeah, we're putting a 1U CubeSat into space. I was like, okay, first of all, what's a CubeSat? What's a 1U? Like, what are you talking about? And honestly, the community was just so strong. And so I found it very easy to be able to learn about these topics, which sometimes are very hard to approach if you don't have necessarily like a supportive community around you. So I do want to say like also like the Stanford Space Initiative has been so instrumental towards me getting involved in the space industry as a whole. And I would say it really started there.
That's awesome. I think the first picture of my talk was a picture of a night sky, and I think it's how it started for me. And when I was a kid, like 7-year-old, something like this, my mother is always saying that I was asking questions about the stars and the moon when it was changing shape. And these questions just grew up with me, and I still have a lot of questions, and it's being curious, I feel, that space enables us to better understand. When you look at the different planets, why are they so different? Why do we have gas giants? It doesn't make sense. So trying to better understand this, and it's just a quest for a whole life.
What have you found most surprising when you entered this realm of space technology?
I don't know if it's the most surprising or the most annoying, is that we'll never know for a lot of things until we go there, and even then we'll not know everything. When you're thinking we are living on Earth, we've been living on Earth, there are so many stuff we don't understand about Earth. If you go deep in the ocean, we don't know much. So it's this, I'm very curious, I said it, it's knowing that I'll never be satisfied, I will never have all the data and everything to understand what is happening.
What about you, Ashley?
I would say, like in terms of the most surprising thing.
Yeah, for you, when
industry?
you entered this space adventure.
I guess I would say, not necessarily always in a negative way, but the lack of centralization of data in this field. So I think something that happens a lot is space companies or even like university teams work very independently of one another. And so what you'll see happen a lot is someone invented some really cool technology, except no one else gets to expand off of it, or learn about how that even worked in the first place. And so we've been trying to collaborate more with the university teams, but just historically, it's been very difficult to be able to, for example, if another university CubeSat team launched their satellite, they don't normally release their data or work with other universities to try and figure out, oh, how can we help you in making your satellite even better? How can Stanford make other people's satellites even better? I think something that would be really interesting to see is maybe how like data will be shared in the future, especially as space continues to grow.
What about you, Sam?
I'm actually going to agree with Victoria here. The question of we will never know. No matter how much data we gather, we will never know everything. And it's really fascinating to me how we have different pieces of data from different spacecraft. For example, Hubble and James Webb, they take pictures and we have that piece of data. But then we also have communication satellites and like Earth observation satellites that send down numbers more so. And we have those pieces of data. But these pieces of data do click together, but we will never completely have the full picture. And also because we don't have the spacecraft to go deeper out into space, like around black holes, for example, and even outer space farther than the galaxies. And since the universe is also expanding very fast, there's a limit to how much we could even travel if we were able to get to that point. So I agree with Victoria.
So you're all very curious people, you know, constantly exploring and helping others to explore. What are some of the questions about space that you hope will be answered in your lifetime? Just something you're insanely curious about, saying we're on our way to answering this, and I'm hoping that I will live to get the answer.
I think for me, and probably for a lot of people, is there life elsewhere? And the big question is, what is life? What do you define as life? So I'm not an astrobiologist. My training is not in that, but I'm working with astrobiologists at Goddard. And they tell me this anecdote about when you have a room full of, let's say, 100 astrobiologists, and you ask them, what is life? And you'll have 150 definitions. So do you have, like, how do you define it? And are we going to find life the same as Earth somewhere else? Probably not. So how to have this agnostic search for life? So maybe one day.
So what do you think? What's your prediction? Will we find some?
Oh my God, I'm working on NASA. I don't.
Do you know something we don't know?
Maybe. I don't think we'll find human life in our solar system, personally. I'm working on a mission going to Titan. So Titan is a moon of Saturn. The name of the mission is Dragonfly. It's very exciting. And the chemistry is just so different. You know, on Earth, we have this water cycle, rain, clouds, seas. There it's methane. So just the chemistry is different already. So can we say that the life that we'll find there, if there is some, will be exactly the same as Earth? I'm not really sure. But let's wait until 2035 when Dragonfly is on Titan, and we can have weeds in
we'll
whatever
get
number
you
of
back
years.
in 11 years and
Let's do
we'll
that.
ask you that question. What about you, Ashley?
Gosh, I guess I would say, how are we going to even power deep space technologies in the first place? Something that people have been talking about is, okay, well, we can slap a bunch of solar panels on the sides, and we can try and make more efficient ways of generating power for our missions, except once you start getting to a certain point in the solar system and going so far, especially to investigate maybe these new lives that are new, like possibly new organisms that you can find in deep space, how are we even going to get there in the first place? So what I'm curious about is, will this be like nuclear technologies, or is this going to be something we haven't even discovered yet, or just generally what is that going to look like?
Oh, sounds fun. How about you, Sam?
I think I really want to see people land on Mars. There's so many challenges with that, because how do you get them back? Because it's
if you want to get them back, you know, who would you want to send to Mars?
And a little bit of background is it's so expensive to ship them one way, so it would be double the price or more expensive to ship them back.
Would you go if you had the chance?
I would go if there's a return ticket. I like Earth very much. So.
What about you? Would you want to be an astronaut? And
My parents have asked me, they're like, oh, so you like space, like you want to go to like the moon? And I was like, I'm sending them there. Focus on that side.
And you, Victoria, would you sign up?
To go to Mars and stay there, no. To come back, probably. But Earth is a great place to be on.
I'm glad to hear. You know, in the preparation for this conference, we had discussions with all the speakers, and that was super fun. And I remember a discussion with you, Victoria, and in your original slide design, which was, you know, you had a lot of stuff in there. But one slide in particular, you likened your job to that of a detective. Yeah. And I just wanted to go back and ask you about that, because you didn't have time to put it in your talk, but I thought that was really interesting. So tell me more about it. Why do you feel like a detective at your work?
When I first met with Margot, I went through 25 slides, and it's like, I know it's too much, I know it's too much. So we kept that for the panel, and that's awesome. I think, as you said, we're all curious, and I'm sure everybody in the room here, basically we have a problem, and we're trying to find the data that is going to help us tell the story. And it's like the same as when there is a murder. I also read like mystery movie like this, so that helps. There is a murder, and we have these clues that can tell us about what happened. We also have to learn how to be objective. You know, we talk a lot about bias in data science, in machine learning algorithm. So as a detective, when there is a murder or a crime, we are supposed to keep being objective, be very meticulous, be very organized, and just let the clues tell what happened. So I feel it's exactly our role. You know, we have a problem, we really try to understand the problem, working very much in collaboration with the clients, in my case it's scientists, and to collect the data in a non-biased way, if we can, and find who the murderer is. But
so you're like the Sherlock Holmes of space.
I would love that.
Yeah. What do you associate with that? Do you?
Yeah, I think so. I think my day-to-day job is very much like a detective, because we don't have all the data. And so, for example, when OtterPub was spinning, we were lucky to know that it was spinning very fast, but then we had to put a lot of pieces of the puzzle together. For example, we knew it was spinning at the rate, but it was also orbiting the Earth as it was spinning, so it's like going crazy in orbit somewhere. And for the torque rod recovery, we had to get information about the magnetic field around Earth, that's the word. And because the interactions are very dependent on the time and the orientation of the spacecraft, we really had to play the role of a detective to rescue it.
Yeah, and I also want to basically echo the same message. Something I would like to talk about is like a weird anomaly we had with our GPS data. It was actually always in like one hemisphere of the globe for a period of time when we retrieved our data, and we're like, gosh, why is it not going anywhere? And I guess like in this scenario, you're basically acting as a detective going, okay, is our satellite defying the laws of physics, or did we make a bug somewhere in our code? And we were able to actually correct all of that data simply by going through how we had processed the information for the GPS data, and we had actually had a sign error, which put it all on the wrong side of the world. And so like in this scenario, obviously that's very important to recognize. And so I like to think of us as detectives, that's a great way of describing it, for being able to figure out, let's say, like the performance of your satellite.
So you're all data scientists and working in an environment where you have to help find answers pretty quickly for your managers or project leads to make decisions that can have big implications for the success or not of your mission. So let's talk about trust, because here you're asking, as a data scientist, your managers to trust the algorithms that you're using. And we all know, because we work in this space, that our algorithms are fantastic, but they're not always to be trusted completely. So how do you deal with that? Do you find it hard to convince people to trust, say, machine learning outcomes, AI algorithms, and say, yeah, you know, we know what we're talking about, and you can rest assured that within the 24 hours or the 36 hours that you were talking about, we can make this decision that is going to help us forward?
I love this question. I think trust, at least in my research, is really one of the main topics I need to emphasize with the people I'm working with, the management to get money to continue this research, but also the scientists to make sure that the science is being returned to Earth. And my background is engineering, so I really want to develop what we call TRL for technology. It's technology readiness level that we use a lot at NASA and in space sciences. And I want to have the trust readiness level with machine learning algorithm to explain, if we go to Mars and we have this type of instruments, this is the algorithm that already flown to Mars and they show that it worked. And if we go to Titan, it's something else, but really have this scale that showed we made it work before. It's a very much iterative process, and it's very hard. And I think our job as data scientists is to understand the data, as I finished on my slide, but it's also to understand the tools that we're using. We talk about this black box, and it's not a great way to explain what we're doing, because we should understand the math and the algorithm we're using before using them. It's the same as when we're in the lab, and yeah, there are some lab safety rules, like don't make your lab explode or don't burn the instrument. It's the same with algorithm. Even if it's on a computer, it's the same. We have to have some lab rules. Don't do assumptions that don't make sense, that is going to make your science wrong.
Have you had problems convincing your professors, Ashley, with SSSI, to trust what you're doing with your CubeSat projects?
As in, like, just data-wise?
Yeah.
Well, I guess the interesting part is, keep in mind, like, our satellite was only operational for maybe like 2.5 months. So you have to be making decisions pretty quickly during this mission life cycle. And so in that scenario, I would say we didn't necessarily experience skepticism from professors, except more so among ourselves. And so what we've been trying to do more of is try to develop like more redundancies in our systems. And so, for example, I was talking about navigation payloads, and something we've tried to do more of is, hey, like, do we have multiple ways to measure what we think the attitude is of our satellite, or which way it's pointing? So this might be like light sensors, it might be the star tracker I talked about, which are both going to be on board, and other measurements like the IMU data, GPS data, and so forth. So I would say among ourselves, yes.
What about you at Starfish?
Yeah, so I'm actually going to take a slightly different approach and say that in space, when like testing algorithms, for example, when sending code up to space, you shouldn't just trust one person. You should trust the data. You should trust several people to review it. You should have a process to review the data, and the data will show you whether you're doing well or not, because it's very easy for one person to make a mistake. And so I think at Starfish, we definitely have a culture, and I really appreciate our co-founders for setting it up, that we do trust everyone. They give us really difficult tasks, and they give us a lot of responsibility because we are a startup with limited people, so we're all doing really important things all the time. But we also want to make sure that we cross-check the data, and we do proofread each other's code, and we don't just trust the test completely blindly. But yes, that's my response.
Right. Well, I wish you all tremendous success in your careers, and I can't wait to hear back from you in a few years and see what you're up to and what's out there. So thanks very much for joining us.